Hello everyone. Today we'll be discussing the question 2 sum. So this question is asked in Google about 200 times and in Microsoft about 31 times in last 3 months. Okay, so let's read the question. So it is given an array of integer nums and an integer target. An integer target. Return indices of two numbers such that they add up to the target. Okay, you may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, so it is saying that you will be given a nums and a target. And what you have to do, you have to find uh, two numbers from the nums that sum up to target, and you have to return the indices of that element. Let's see the example discuss. So it is 2, 7, 11, 15, and target is 9. Okay. So output is 0, 1. Output is 0, 1 because element at 0 is 2 and 1 is 7, which sum up to 9. And question also says that ki, uh, question also says that you have exactly one solution. Exactly one solution. So we will not get any multiple indices that will sum up to target. So let's discuss the approach. So one of the brute force approach could be we can simply run a double for loop. We can run a double for loop and iterate element by element and check which element sum up to target. So let's see how it will be done. So uh, we will run a loop from this index and another loop from I plus 1. Suppose this is I, okay, and this is j. J will be I plus 1. J will start from I plus 1. Okay, so uh, huh. So we will check whether element at I and J sum up to target or not. If they sum up to target, we can simply return I and J. Okay, suppose if it is something else like 8 and we will have 7 at end. Okay, then in that case we can see that it is not summing up to 8. So what we will do, we will move our J to next means inner loop. Okay, and again we will check whether 2 plus 11 equals to our target or not. No. Again we will check with 15 whether 2 plus 15. No. And at the end we will check whether 2 plus 7 is equal to our target. Yeah, we can see that it is equal to our target. So we will return I and J. So time complexity for this will be n square. So obviously interviewer will not be happy with this time complexity. So he will ask you to optimize. So let's see the optimization approach. Let me clear the screen. So in this optimized approach, what we will do, we will take a map. Okay, we will take a map, and inside that map, what we will do, we will iterate the element, and we will check if target minus element is present in our map or not. Currently, our map is empty. So if I am starting with this index, and we will see whether 9 minus 2 is present in our map or not. So it is not present. Then what we will do, we will store this element 2 in our map along with the index. It is a map, so it will store the key value. So key will be the element and value will be the index, which is 0. So why we are doing like this? Key we are searching for 9 minus 2. Because we know that if we need to find a plus b, if it is if it sums to target or not, means if a plus b is equal to t, then a will be equal to t minus b. So the same thing we are doing. We are subtracting b from our target, which is in this case is 2, and we are searching for a. Okay, so 9 minus 2 is not present. So we will move to the, we will store this 2 and move to the next index. Again, we will search 9 minus 7 is present in our map or not. Yeah, we can see that it is present. So we are currently at index 1 and we have the index of 2, which is in our map. So we can simply return the index 0 and 1. Okay. Okay, suppose if it is not 7, if it is 8 and 7 is at end. Okay. So we will check whether 9 minus 8 is present or not. Yeah, we can see that it is not present in our map. So we will store this 8 in our map along with the index and move to the next index, which is 11. Now we will see 9 minus 11 is present in our map or not. We can see it is not present. Again, we will store 11 along with the index and move to next element. Again, same 9 minus 15 is not present, then we will store 15 and move to next element. 15 with index 3. 0, 1, 2, 0, 1, 2, 3. Yeah, 3. So now we reach 7. So we can see that 9 minus 7 is present in 9 minus 7, which is 2, which is present in our map. So we will return the index 0 and 4, which is the current index. So in this, time complexity is n, O of n, and your space complexity is also O of n. But in the previous one, the time complexity was O of n square and space complexity was O of 1. Okay, now let's see the code. So we have taken a map and we are running a loop on the nums, and we are searching whether target minus nums is present in our map or not. If it is present, then we are simply returning the index of that element and the current index and if it is not present, then we are storing it into the map and again revisiting. Yeah, so let's run this code. Yeah, it passes our given sample test case. Let's submit the code. Yeah, so it successfully passed all the test cases. So this is not the end. In interviews of product-based companies like Google and Microsoft, they usually ask follow-up questions. So one of the follow-up question on this two sum could be ki if you are given this nums as sorted, this num is sorted, okay, and in that case you need to uh, find the solution. Then this code obviously this code will work, but the time complexity for this code is O of n and space is O of n. Okay, so this will work, but interviewer may ask you to optimize the space. Okay, so let's see the follow-up question on this. It is it is in the Leetcode as to sum 2 input array is sorted. Okay. So it is same as the to sum only, but in this case, input array will be sorted. So let's discuss the approach in this case. In this case, you know that your input array is sorted. So you can utilize this information to optimize your code. Okay. So if it is sorted, then what you can do, you can use a two-pointer approach. You can do two-pointer approach. You can place one pointer at the beginning and one pointer at the end. Okay. And sum them. 15 plus 2, which is 17. And check whether this is equal to the target or not. If it is equal to the target, then simply you can return the pointer's value, A and B. Suppose the pointer name is A and B. Okay. So you can simply return that, but it is not equal. So if it is not equal, then you check whether this value is greater than our target. If it is greater than our target, then we need to minimize our sum. Okay, because it is greater and our target is less. So we need to minimize this value. So to minimize this value, what we can do? We can move our pointer which is at the end, because larger elements are at the end. And if we want to minimize the sum, then we need to simply move our pointer at the end to previous element. Because it is sorted, then it is obvious that previous element will be lesser than the next element. So if we will move to the previous element, obviously it will reduce our sum. So we will move our pointer to move our pointer back by 1. Now again we will sum 11 plus 2. So this time 11 plus 2 is 13. Again we will check whether it is equal to our target or not. If not, if it is equal, then simply we can return the pointers. Okay. And if it is not equal, again we will check whether it is greater. Yeah, greater. Then again we will move the pointer back by 1. And suppose if this element is lesser than our target, then we need to increase this sum. So to increase this sum, we will need to move the first pointer, because the next value will be greater. So if we'll move the pointer A to next, it will increase our sum. So in this case, it is greater. So we will move our pointer B by 1 back. Okay. So now again, we will do the sums and we will check whether 7 plus 2, which is 9, equal to 9. Yeah, it is equal to our target. So in that case, we can return the pointers A and B. Okay. Now let's see the code. Yeah, we have taken a pointer A, which is at 0, and B, which is at the end of the element. And we are running a while loop till A is lesser than B. And we are finding the sum of the pointers, sum of the elements of element at the pointers, which is number of A plus number of B. Okay, and we are checking if sum is equal to target. Then we are returning A plus 1 and B plus 1. We are returning A plus 1 and B plus 1 because in question it is given that yeah, this added by 1 as an integer array means we need to add 1 into our index, means they want in 1 base indexing. That's why I have added 1 to both. Okay, next we are checking if sum is lesser than target. If sum is lesser than target, then we need to increase our sum. So to increase, we will increase our first pointer A. And if it is greater, then we will decrease our last pointer. So in this way, we will get our result. And the question says that exactly one solution exists. So this condition will never come. So let's execute the code and check. Yeah, so it passed all the given test cases. Let's submit it. Yeah, it has passed all the test cases successfully. Yeah, thank you for watching.